Lab 2, Gaussian Beam Profiling and Propagation. I'm Nathan Isham.
I'm Alan Ye.
I'm Stephanie Wells.
And we share the workload this time as well.
So for the setup of this lab, we use the same procedure from Lab 1 to align the microscope and the laser. So to profile the beam with a knife edge, first we focus the microscope objective to the surface of the laser, and we mark it as a reference location. And the rest of the locations throughout the experiment will be based on this reference location. So we move the knife edge roughly 800 millimeters away from the reference location. And then using the microscope objective to determine its precise location. So we place the photodiode right behind it. And we scan the knife edge across the beam in the X direction using the translation stage. So with an increment of 10 micron, we record the power measurements with the photodiode. Then we move the knife edge to two other arbitrary locations closer to the reference location. And then we use the same procedure for two more power measurements.
To determine the location of the knife edge, we use the reference point for the microscope, as well as the new point that the microscope is at. And then we move the knife edge so that in front of the microscope and covered half the beam, and move the knife edge until we got best focus on the half circle that was imaged from the knife edge. For the second part of this lab, we placed the microscope 400 millimeters away from its reference point in front of the laser. We then put in the lens and focused the lens on the microscope to position the lens 400 millimeters away from the laser. After we had the lens in place and that we had it aligned with the system, we moved the microscope back and removed the safety cover from the laser so that we had the laser going down the path now. We then moved the microscope along the z-axis until we found the spot that provided the least sensitivity for the spot as a function of the screen distance. Ideally we would have found a position where the beam came out collimated, but due to diffraction effects and the fact that we use a 0.4 NA objective, which made it very sensitive to the Z position, we were unable to find that spot. Once we had found the position of the new beam waist, we did the knife edge test both in front of the new beam waist and behind the new beam waist.
We were able to record our power outputs for each knife edge position and normalize the data to get a Gaussian beam profile. We had these at E1, E2, E3, and then our new beam waist when we added a lens to the system. This is for in front of the new beam waist and behind the new beam waist. We were able to calculate the beam waist using the 16% and 84% and taking the difference between these two values. For the first three beam waists, they were about the same. For the beam waist in front of, or the normalized power in front of the new beam waist, it was higher, and behind the new beam waist was lower. We believe that due to the positioning and being arbitrary, this could affect our values for the beam waist.